So, encoding and decoding messages with matrix multiplication is a way that you can send secret messages by using matrix multiplication to create and solve them. The way you can do this is each letter has a corresponding number in the chart that you can see right there. So, A equals 1, B equals 2, and so on and so forth. So, you can use that to create words based off of, like, if you put numbers in. Like an example problem is right there. When encoding and decoding messages using matrix multiplication, you can use a 2 by 2 matrix or a 3 by 3 matrix. Whichever one you pick is going to decide how you split up your message. For example, if you're using a 2 by 2 matrix with the message, hello, how are you? Then you will split it up like the following. Your first 2 by 1 matrix will be HE followed by LLOHOWAREYOU. Obviously, it's going to be the numbers that correspond with that and not the letter. However, if you're using a 3 by 3 matrix, your message will look a bit different, as it will look something more like this. And it'll be split up into 3 by 1 matrices, and this will be HELLOHOWAREYOU dash. The dash represents the space left in the matrix that can't be left unhandled or untouched, so we just add a dash, and that's going to be the number 27. You will also have to specify what your matrix A is equal to, which is going to be the number, the matrix that you're going to be multiplying your messages matrix by to encode it. That way people can't just read it off the graph. So here are the steps for encoding messages. So first, divide the letters of the messages into groups of 2 or 3, which is you choose if you want to do a 2 by 2 matrix or a 3 by 3. Next, you're going to want to convert each group into a string of numbers by assigning numbers to each of the letters in the messages. Remember, that's what we did. A equals 1, B equals 2. Then convert each group of numbers into column matrices. So your 2 by 1 or your 3 by 1. Convert these column matrices into a new set of column matrices by multiplying them with a compatible square matrix of your choice that has an inverse. This new set of numbers or matrices represents the coded message. And I'll show this on the next page. So here's an example of this. So we have use matrix A equals, and we have 3, 2, 1, 2 to decode the message, hey, what's up? So first we're going to take our message and we're going to convert it into the number values. So H equals 8, E equals 5, Y equals 25, and then the space in between is going to be 27, then WHATS, then another space, and then up. Then you're going to use matrix multiplication to multiply matrix A by your message to complete your encoding. So right there's an example of it. And this would be the final answer. So this would be your encoded message, which is 34, 129, 85, 43, 111, 95, 18, 79, 39, 41, 73, 53. Now we're gonna look at how to decode it, because obviously a number like this just seems stupid and there's nothing behind the meaning of it. So, decoding messages with matrix multiplication steps. You're gonna take the string of coded numbers and multiply it by the inverse of the matrix that was used to encode it. So your matrix A, you're gonna take the matrix A to the negative first power of it, and we'll show you how to do that on your next page. And then once you solve this, you'll have a set of numbers. You'll associate the numbers with their corresponding letters to find out your hidden message. So here's an example of this. We did a 3 by 3 on this one. Use matrix B equals 1, 1, negative 1, 1, 0, 1, 2, 1, 1 to code the message, which if you did it correctly will end up being hold fire. So first, we're going to have to find the inverse of matrix B, which is going to be B to the negative first, which equals 1, 2, negative 1, negative 1, negative 3, 2, negative 1, negative 1, negative 1. So then, this is going to be the coded message that you thought of, which mine was going to be 11, 25, 20, 20, 10, 14, 43, 41, 41. And you can find this out by taking your matrix B and dividing it by what hold fire should be, which is this number right here, and then it'll give you the starting number, which is that, which you would have to put in the middle. So finally, you're going to multiply the inverse of matrix B by your decoded message. So you have their matrix B to the negative first. You have your encoded message here. And then you have the final result, which if we look at it, if we go back to the previous slide, 8 is H, 15 is O, 12 is L, 4 is D. So that says hold. We have 27 as our space in between. 6 is F, 9 is I, 18 is R, and 5 is E. So that gives us our message of hold fire, which is the correct message. And that's pretty much it. This is just a cool way of being able to send messages, like, say, between your friends. Obviously, you would have to learn it, but it's pretty easy. I mean, I would say decoding is way harder than encoding, because encoding, all you really have to do is just think of a matrix A and then make up a message and then just put it into the numbers and multiply it, and you'd get a random jumble of numbers. I mean, no one's gonna guess what that is, so yeah. And that's really it.